Welcome to Let Me Fix This. Enjoy the video.
You start by setting a reproducible environment. Create a Python 3, 9 plus venv or conda env, and install OpenCV and NumPy so you can run examples immediately. Learn the smallest math pieces that matter, vectors, matrices, eigenvalues, and basic probability, because they explain why algorithms behave. Once that's done, run a simple script to load an image, convert to grayscale, and show edges. This first loop gives immediate feedback and motivates deeper study. Now deepen practice by combining classical and modern tools. Implement convolutions, Gaussian blur, and edge detectors to see effect of kernels, then extract features with ORB or SIFT and stitch simple panoramas to learn geometry. Parallel to this, build small CNNs on CIFAR or custom datasets, then apply transfer learning with a pre-trained backbone. Make sure to version datasets and scripts. Iterative experiments teach you trade-offs between model size, accuracy, and inference speed. Finish by turning experiments into a reproducible pipeline. Freeze model weights, export to ONCs, and run inference on sample images while measuring latency and accuracy. If performance lags, apply pruning, quantization, or smaller backbones and repeat your benchmarks. If training fails, inspect the dataset and labels first, then check augmentations and learning rate schedules. These are the most common culprits. Keep logs and small reproducible tests so you can quickly diagnose and fix issues.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.